Mr. Madden's Math Minutes.
Sit back, relax, and get ready to learn. You give me 10 minutes or less, I'll give you a math lesson.
That's my dad.
Hello, and welcome to the video that will help us find the measure of a missing angle. Part 2. Now what we have here is a protractor, which is a tool commonly used to measure the size of angles. So you can see that this protractor goes from 0 all the way up to 180 degrees. But this protractor is only showing you half the story. Here is a full protractor, and you can see it measures from 0 all the way up to 360 degrees. Now it says 350 here, but if I keep counting these by ones, we will get up to back to where we started at 360. Now what does this protractor look like? Well, it looks like a circle. So when you make one full turn and end where you started, you have just turned 360 degrees. Looking at this figure, we want to find the measure of angle x. Okay. Well, we do know the measure of this angle is 100 degrees and the measure of this angle is 80 degrees. So we have this measurement, and we want to find this measurement. Now take a look at that red I just drew. Looks like a circle, doesn't it? So the full turn, the full circle, is going to be equal to 360 degrees. So we know that 100 degrees plus 80 degrees plus x equals 360 degrees. So what we would do next is we would combine our 180 to get 180 degrees plus what's ever left will equal 360 degrees. And we had then subtract 360 degrees minus 180 degrees. And subtract our ones, we get 0. We have to regroup. And 16 minus 8 tenths will give us 8 tenths. And 200 minus 100 equals 100. So the missing angle is 180 degrees. Another way to look at it is if from here to here measures a total of 180 degrees, that looks like half the circle, doesn't it? Right? And let me use another color. This side, this angle looks like a straight line, doesn't it? And we know that straight line angles equal 180 degrees. So that's another way you could figure it out mentally. Let's look at another example. So if I start at the spot and go all the way around, showing all the angles back to the beginning, I do have a circle, which means the total of all three angles, if this is angle A, B, and C, the total of all three will equal 360 degrees. So if I were to write an equation, I could write 120 degrees plus 90 degrees plus x equals 360 degrees. Now I don't see any straight lines, so I know I'm not going to be working with 180 for any of these. I know I have a right angle right here, and an obtuse angle right here, and this angle, if I turn my head or the paper or the screen, appears to be obtuse as well. So I think that x should be greater than 90 degrees. So if I combine my 120 and 190 degrees, let's do it here on the side. 9 plus 2 is 11. All right, you get 210 degrees plus whatever's left will equal 360 degrees. 360 minus the 210 degrees that we know will give us 150 degrees, which is greater than 90 degrees. So that is an obtuse angle. That's how we found the measure of the missing angle. Sounds like a mystery. Let's talk briefly about vertical angles. Vertical angles are angles opposite each other when two lines cross or intersect, as they do right there. Now they're called vertical because they share the same vertex or center point, which again is right there. One thing that's interesting about vertical angles is that the angles that are opposite each other are equal. So angle 1 and angle 3 are equal in measurement. And likewise, angle 2 and angle 4 are equal in measurement. So looking at this example, here we have two line segments that are intersecting, and they're vertical angles. And you can see that we have 33-degree angle here. Opposite is another 33-degree angle. And on the top we have a 147-degree angle, and on the bottom opposite it is another 147-degree angle. Now if we added up all four angles, guess what we would get as a total? Looks like a circle, doesn't it? So we get 360 degrees. Let's use that to solve one more problem. Alright, so here we're going to write equations using variables to represent the unknown angle measurements. Find the unknown angle measurements numerically. Here you can see we have intersecting lines forming vertical angles. So we kind of know right off the bat that if this angle is 55 degrees, x is going to equal 55 degrees. And whenever y equals, x will also equal. But we have to write equations for each step. So number 1 down here shows us we're going to find the measure of angle x, and we have to write an equation to find that measurement. Well, it says we have to go in order. If you take a look at this line, this angle that is formed here doesn't look like a straight line. So that means that 55 degrees plus y is going to equal a straight line angle, or 180 degrees. So to find the measure of angle y, we'll take 180, subtract 55, and get 125 degrees. So angle y equals 125 degrees. Now if angle y measures 125 degrees, guess what we also will know? The vertical angle, which is angle z, will also equal 125 degrees, won't it? Now let's find the measure of angle x right here. Okay, we're going to use angle y to help us out. If we look at this angle here, looks like a straight line, doesn't it? So that means that over here for number 1, 125 degrees plus x is going to equal 180 degrees. So I'm going to take 180, subtract my 125, and get, presto, 55 degrees. X equals 55 degrees, which we said that earlier, didn't we? So now to find the measure of angle z, I can look, say, at this line and say this is the angle. Straight line. Part of that angle is 55 degrees. What is the rest? So I know 55 degrees plus z, I put a line through it so it doesn't look like a 2, equals 180 degrees. So when I take 180 degrees and subtract the 55 degrees, I get, presto, 125 degrees, which if we look directly across from y and z, they are vertical angles. So that makes sense that angle z is 125 degrees, just like the vertical angle y, which equaled 125 degrees. So feel free to watch any portion of this video. Enjoy the rest of your day. We'll see you soon.
This is Mr. Madden saying thanks for watching. I hope it helped, and whatever you are, be a good one.